Okay, so a rational number. Basically what a rational number is a ratio of two integers, like a 3 and a 4. It's a rational number because it can be made into a fraction. So anything that can be made into a fraction is essentially a rational number. So keep that in the back of your mind. There are other things that you can also kind of write down and remember. Rational, obviously we said it can be written as a fraction. So a whole number, we know we can take a whole number like 3 and put it over a 1. Well, that's a fraction, so that's a rational number. A mixed number also can be made into an improper fraction, which is also a rational number. Now these two, a terminating decimal, meaning a decimal that comes to an end, like 0.342. That we know we can make that into 342 over 1,000, which is a fraction. So that would also be rational. A repeating decimal, like 0.66666, that goes on and on and on. That is also considered a rational number. So rationals repeat is a good way to remember that. A perfect square, like the square root of 25 would be 5. That's a perfect square, the square root of 25. 25 is a perfect square. So that can be made a fraction, that is rational. What is not a rational is anything that can't be made into a fraction. It's not a fraction. A decimal that does not repeat, a decimal that does not end, or a non-perfect square. These are all irrational numbers. The most important being you can't make it a fraction, okay? So let's look at a couple of examples. See if we can figure this out. Okay, 2 over 7. Well, clearly 2 over 7 is already a fraction, and because it's already a fraction, we know that's rational. 6, well, again, we can make this 6 over 1, so that would be rational. 3 2/5, again, 3 times 5 is 15 plus 2, that's 17 over 5. That's rational. 0.5, we know we read 0.5 as 5/10, correct? So 5 over 10, which is 1/2, which is rational. 0.3892, tens, hundreds, thousands, 10,000, so it would be 3,892 over 10,000. Clearly also a fraction, also rational. So all of these so far, we can make them all into fractions. We can also make this into a fraction, can't we? It would be 3 26 hundredths, right? We can simplify that. 3 13 over 50. And let's see, and if we did the math there, we can also make it an improper fraction, which would be 163 over 50, which again is another rational. So all of these are examples of rational numbers. They can all be made into fractions, and let's look at a few more examples. This is an example of what we call a repeating decimal. The little repeating line on top means that 3 goes on and on forever. 0.333. And that is always considered a rational number. Now, if you think of it this way, you know, if we were looking at 1/3 and we went ahead and did that division, we would do the top dog in the doghouse, right? And if we did that division, what do you think we'd come up with? Well, we'd come up with the 3 over here, have 1 left over, and guess what we would get on top? We would get this repeating 3. So that 0.33 we've just proven is equal to 1/3, which, guess what, is a fraction. So that's why these numbers, these repeating numbers, are actually rational. Hopefully you can see that all. And then the square root of 25 is 5. which is rational because we know 5 over 1 is a fraction. The square root of 26, this is a non-perfect square. Because it's a non-perfect square, it's never going to come to an end. It's not repeating, it's not terminating, so it is irrational. Square root of 2, still the same thing. These are both prime numbers. Anytime you have the square root of a prime number or a non-perfect square, they're irrational. And this is the most classic example. You see this a lot on a test. Pi. Pi is will always be an irrational number. It's non-repeating, it's non-terminating, meaning it doesn't come to an end. So it would mean that it is an irrational number. So hopefully this all makes sense to you. I would go over that list again and just make sure you have straight in your head the difference between irrational and rational. This is a handy list, and hopefully that helps. Replay this and think about it some more.